Okay, so we're going to talk about areas of circles and sectors today, but first, I would like you to take a look at this warm-up question. 1/3 of a minus b squared would be what? I'm going to go ahead and scroll down just a little bit so you can see all the options. 1/3 of a minus b, I'll rewrite it so we can see. 1/3 of a minus b squared. Pause the video for 2 minutes and tackle this one real quick. Okay, if you squared and then you ended up with 1/9 of a squared minus b squared, distributing that squared, you would be very wrong. Remember, when we are multiplying a binomial by itself, oops, 1/3, not 1/2. And so I got to distribute 1/3 times 1/3. That is 1/3 of a squared. Then we have to do 1/3 of ab. So you got to distribute this way also. Then we're going to do this one. That's another negative 1/3 ab. And then negative b times negative b is a positive b squared. So we should have negative 1/3 a squared minus 2/3 ab plus b squared. So I'm thinking this is not negative. I don't know why I wrote that. H. All right. Areas of circles and sectors. Remember the formula for the area of a circle? Area is equal to, no, pi r round, cornbread r square. I know, I already made that joke. But you're right. Area is equal to pi times the radius squared. And here's kind of a proof of that. If we cut a circle into all these little pieces, and all these little pieces are called sectors, we'll get back to that in a minute. If we cut it into a whole bunch of tiny little slices and then stack them kind of in alternating directions in this situation, you'll see that we end up with a parallelogram. Area of parallelogram is base times height. The height would be this guy right here. And if you think about what that picture, what that represents of this slice, wouldn't that be this right here? Which is also the radius, right? And then this guy right here is going to be half of the circumference. Half because the other half's down here, because we're alternating, right? But if I took all of these curved pieces right here and added them up, we're going to get the circumference. So it's just base times the height. So the circumference of a circle is 2 pi times the radius, right? And then we're going to multiply by another radius, because this is the base of our little parallelogram. That's to do times the height. Well, the height is just another r. But my base is actually only 1/2 of that. So the 1/2 and the 2 cancel, and I get r times r, and that's where pi r squared comes from. Okay, so a typical bag of cheese will cover 400 square inches of pizza. How many bags are required for 5 18-inch diameter pizzas? So let's say we have 400. We got to figure out what our areas are first. I'm sorry. Area is equal to pi r squared. If 18 is the diameter, that means that the radius is 9. Okay, so I have 81 pi. I'm going to leave it in terms of pi for a second. That's the area of 1. But we need 5 of those. So I need to do 81 times 5. And I actually get 405 pi, which is approximately, can be a little bit more than 3 times that, 1272.3. Well, 1272.3 inches squared. The question is, if each bag does 400 square inches, how many do we need? So if I divide that by 3, or 400, I mean, excuse me. If I divide that by 400, we get 3.18. So we better get 4 bags. You can't get part of a bag, so you better round up. Outdoor Accessory Company makes circular covers for outdoor umbrellas. If the cover needs to be 8 inches longer than the 72-inch diameter umbrella on each side, find the cover in square inches. Drawing a picture is going to help a lot here because you can kind of picture what's going on. This has to be 8 inches. and this has to be 8 inches. So our total diameter here is 78 inches. Can I make this any smaller? All right, so 78 inches is our total diameter. So divide that by 2. Our radius is going to be, what, 39 inches? So area is equal to pi times the radius squared. So pi times 39 squared. The area is approximately 4,778.36 inches squared. I say approximately because remember pi is an irrational number. It goes on forever. So in order to actually write down the definition of what pi is, you would have to be writing forever, and I can't. Right, so it goes on forever. So anytime you multiply by 3.14159 or just 3.14 or any approximation of pi, we are getting only an approximation, but it's pretty close. On your own, find the radius of a circle with an area of 95 square centimeters. So I say on your own, but then I did all the work here for you. All we got to do is plug in 95, divide by pi, and then take the square root, right? Anytime you take the square root, you're going to get two options. But remember, just like we just said, it can't be negative because it's a physical thing, right? We have a physical length. That can't be negative. So it's going to have to be the positive square root. A sector is a region of a circle. Why is that happening? It's a portion of it, and the size of it is determined based on the size of that central angle. Okay, so the definition of sector, let me move this thing so you can see. It's a region of a circle bounded by a central angle and its intercepted major or minor arc. So this thing right here is an arc. Depending on how big it is determines whether it's major or minor. Okay, major arcs are larger than 180 degrees, minor arcs are less. So for example, a slice of pizza is a sector. It's just a portion of a circle. So imagine I tell you the whole circle has an area of 24. Find the area of the following sectors. Well, how much of the circle is this 90 degrees? Isn't it 1/4? So it's going to be 1/4 the area of the original circle. So 1/4 of 24, which would be 6. What portion of the circle is this guy? How many 30-degree chunks could we put into a circle? The 90 degrees is easy. We can see it. This one's not so easy. How many degrees are in a circle? 360. Just divide by 30 to figure out that we could get 12 of those. So I really just need to do 1/12 of the 24. This one would be 2. 110, that's a weird portion. It's not going to work out neatly. So I just take the total, 360 degrees in the circle, divide by the 110. And that's going to give us 3.27 repeating. Okay. Or sorry, yeah, 3. So I should have done the other way around. 110 divided by 360. That'll give you a fraction you can use. We can put 3.27 of these regions in the circle, but I want the fraction the other way around. I want to know that it's 0.3055 repeating. That is how much of the circle this thing represents. So I do 0.3056 times the 24. Oops, that's terrible. 24. The area of this guy is 7.3 repeating. Okay, so the formula for an area of a sector is simply the ratio of the central angle to the entire circle. Okay, we're setting up a proportion basically, and then solving that proportion. Here's the proportion. Area of the sector divided by the area of a circle is equal to the measure of the sector over the measure of a circle. So if I multiply by pi r squared, this right here is just area of a circle. And then here's the ratio. What fraction of the circle does that sector make up? So for example, this guy. I first need to find the area of the circle. Area of the circle is equal to pi r squared, so pi times 4 squared. So area is going to be 16 pi. I'm just going to leave it like that for now. This is 53 degrees divided by the total 360. That is 0.147 of the total circle. So 0.147 times the 16 pi Now you could go ahead and multiply by pi. So 16 pi times the 0.147. I get approximately 7.4 feet squared. Remember, we're still talking area, still squared. The units were feet, so we're in feet squared. A jeweler makes a pair of earrings by cutting two 55-degree sectors from a disc of silver. First, find the area of each sector, and then we're going to talk about the weight. If the weight of the silver disc whole is 2.3 grams, how many milligrams does the silver wedge for each earring weigh? Okay, so first let's just do A, find the area of each sector. So go ahead and pause this and then tackle that. Okay, for A, we need to do 55 degrees over 360 times pi. The radius, which is right here, is 2 centimeters times 2 squared. So I have 55 over 36, 360 I mean, times 4 pi. So the area of each sector is equal to 1.9, I get 1.919, so 1.92 centimeters squared. That's for each, because I did 55 degrees. I can now double that if I want the area of both, but we also could have just added the 55 degrees together and done this area of 110 degrees to find the area of both earrings. Okay, part B. If the weight of the silver disc is 2.3, how many milligrams does the silver wedge for each earring weigh? Well, remember, it's 55 360ths of a circle times 2.3. So 55 360ths times 2.3, I'm getting 0.35 grams. But the question was, how many milligrams? Watch for units. Milli means thousandth, right? So how many thousandths? So I got to multiply that by 1,000, and it becomes 350 milligrams. Same weight. These are the same thing. They just are in different units. The idea, same thing is going between like inches and feet. On your own, find the area of the... I did it for you, dang it. Well, I guess we'll skip that then. Homework is day 3, I think. Day 3. The next day from the homework sheet, whatever that is. I'm pretty sure it's 3. Good luck. Have a great weekend.